find this derivative, it would be helpful to rewrite this function with this expression here in exponential form. Say that we have the cotangent of x plus 1 to the 1/3 power. Then we'll use the chain rule because there is an outside and an inside. Okay, so now the chain rule coming right up. We do have the power rule appropriate. Take that power, move it out front, leave the inside, subtract 1 from the power. So 1/3 take away 1, well that's 1/3 minus 3/3. And 1/3 take away 3/3. That gives us negative 2/3. That's the outside. But there is the inside. And the derivative of cotangent is negative cosecant squared of that angle. Of course, the derivative of x, the angle, is just 1, and the derivative of 1 is 0. Okay, well, let's see what we can do to simplify. We do have a positive times a negative. That makes negative. We do have a 1 up top, but we don't normally write that. The 3 is in the denominator. I can move this base to the denominator to make that power positive. We would have cotangent of x plus 1 to the positive 2/3 power. Up top, I still have cosecant squared of the angle. Now, can I do any simplifying? Maybe a little, not so much. I could toss that cotangent x and 1 back into a radical. It would be a cube root radical, and the radicand would be squared. But that's not too exciting. What can I do with cosecant squared x? I could call it 1 plus the cotangent squared. Maybe I would, maybe I wouldn't. So maybe I would stop here. If I wanted to keep on going, I could say that that negative, it can be at the top, it can be on the side. The numerator, I could replace it with 1 plus the cotangent squared if I left my negative on the outside. Down low, we still have this. But what else could I do? Well, really nothing. I can't factor the sum of squares. I can't simplify this radical. So we're finished here or here.